image segmentation? It is basically a subdomain of computer vision. Like nowadays we are using computer vision in various fields. So for that computer vision, we do require a subdomain, that is image segmentation. And we can also say it is a subdomain of digital image processing. So basically this image segmentation, it aims at grouping the similar regions or segments of an image under their respective class labels. So what we are trying to do using image segmentation? We are grouping the similar regions or segments of an image under their respective class labels. Image segmentation, this is basically an extension of image classification, where in addition to the classification, we are performing localization. So image segmentation is a superset of image classification, with the model pinpointing where a corresponding object is present in outlining the object boundary. We basically want that in an image where our object is. So that object can be pinpointed using the object boundary. So here in image segmentation, what we are trying to do? We are trying to group the similar regions or the segments of an image under their respective class labels. Segmentation, it is an important stage of image recognition system because it extracts the object of our interest for further processing, like for description or maybe for recognition. So basically, what is image segmentation? It is an extension of image classification. In this image segmentation, what we are trying to do? Our aim is to group the similar regions or the similar segments in an image under their respective class labels. Where if we see a particular image, we categorize into certain classes. So now, image segmentation, what does it do? It will group the similar regions or segments of an image under their respective class labels. So that is the main purpose of image segmentation. Now we have the types of image segmentation task. The first one is the semantic segmentation. Basically, semantic segmentation, it refers to the classification of pixel in an image into the semantic classes. For an example, we have an image of the crowd in a street. This would have semantic segmentation if the model predict the entire crowd region as belonging to the pedestrian class. So this semantic class segmentation, it will provide very little in-depth detail or information about the image. If we have a crowd on a street, so what will our semantic segmentation model predict? It will predict that entire crowd region as belonging to the pedestrian class. I have told you that segmentation, what is it doing? It is defining our image into different classes. Semantic classification segmentation, it will just predict that crowd region, that it belongs to the pedestrian class. So it provides very little knowledge about that image. Second is instant segmentation. This model, it classifies the pixels into categories on the basis of instances rather than classes. Now, it will not talk about the whole class, it will talk about the particular instance of it. If the same image of the crowd that we talked about in the semantic segmentation, it is fed into the instant segmentation model, the model would be able to segregate each person from the crowd and its surrounding objects. But this will not be able to predict what each region or the object is an instance of. So what will our instant segmentation do? It will be able to segregate each person from the crowd and the surrounding objects. So we have seen that first is the semantic segmentation, second is the instant segmentation. In semantic segmentation, we are classifying the image into semantic classes. While in instant segmentation, we are dividing them into instances. That means if we have an image of a street on which various persons are there, so our semantic segmentation, what will it do? It will just classify it as a pedestrian class image. But what will instant segmentation do? It will mark all the people, all the objects, or we can call them instances, into that particular image and the surrounding objects also. Talking about the third one, that is panoptic segmentation. Now, panoptic segmentation, it can be expressed as a combination of semantic segmentation and instant segmentation. If we combine these two, we will come to the panoptic segmentation. Here, each instance of an object in the image is segregated and the object identity is predicted. Panoptic segmentation algorithm, they find large-scale applicability in the popular task like the self-driving cars, where we want a huge amount of information about the immediate surrounding. Like if we are now getting into the era of self-driving cars, where we will not be having drivers. So if that self-driving car, it sees in the surrounding that what all objects are there, it visualizes them properly, then only it will be able to drive safely. So in that case, where we require a large amount of information about the immediate surrounding, so there we will use the panoptic segmentation, which is a combination of instant and the semantic segmentation. If we want to consider it as an example, if we have the image which is shown in part A, in which there is a beach and 3 persons are standing there. If we talk about semantic segmentation, it will just classify this as a class of people standing there. It will not provide any details about it. In instant segmentation, what will happen? It will determine all these 3 persons as separate instances. Now, in panoptic segmentation, if you are using, it will do the semantic segmentic segmentation as well as instant segmentation. That means it will classify this whole image into a particular class, and then it will also classify all the objects and the nearby surrounding in particular instances. So, for the application like self-driving cars, where we require too much amount of data to understand the surrounding, we use a panoptic segmentation. Talking about the applications of the image segmentation. There are various applications of image segmentation where we are using this process. The very first one is the medical imaging. It is an important domain of computer vision that focuses on the diagnosis of diseases from visual data, both in the form of simple visual data and the biomedical scans. We do have very complex scans where we want to identify each and put every organ, every part of our body. So for those types of medical imaging, we are using this computer vision and we are applying the image segmentation technique there. Then talking about the next one, like we have the smart cities. Smart cities, they often use CCTV cameras for real-time monitoring of pedestrian, traffic, and if any crime is taking place. This monitoring, it can be easily automated with the help of image segmentation. So in smart cities also, where we are using CCTV cameras for monitoring every task that is happening. So there we are using the image segmentation technique to identify all those images which are captured by our CCTV cameras. Third one, robotics. Image segmentation, it aids the machine perception and the locomotion by pointing out the objects in their path of motion, enable them to change the path effectively and understand the context of their environment. If we are talking about robotics nowadays, we are coming where we will be having robots all around us in a few coming years. So that robotics, what does it require? It requires to see the surroundings, see the environment carefully so that it can function properly. So for that purpose, we definitely use this image segmentation. Then we have already talked about the self-driving cars. These are one of the biggest applications of image segmentation, with the planning of the routes and the movements, and it heavily depends on the image segmentation techniques. So these are the few basic applications where we can apply this image segmentation. First is medical imaging. In the field of medical imaging, we do use image segmentation. Then smart cities, where we are using the CCTVs cameras nowadays, we will be using image segmentation. Robotics, the very upcoming field, in that we require the process of image segmentation. And the fourth one, the self-driving cars. There also this image segmentation plays a very important role. Talking about image classification. Image classification refers to the labeling of images into one or more predefined classes. Image classification, if we have an image, we want to label that image into a predefined class. That is called image classification. There can be potentially n number of classes in which a given image can be classified. So image classification, it is again a subdomain of computer vision. It deals with categorizing and labeling the group of pixels or vectors within an image using a collection of predefined tags or categories that an algorithm has been trained on. If we so, what is image classification? This is a super domain of image segmentation, we can say. It refers to the labeling of images into predefined classes. If we are talking about any particular environment, we are capturing few images of that environment. Then we can classify them into different classes. Suppose there's a room in which there are few people who are sitting. So they can be classified into one class. There are some people who are standing and having their tea or snacks. They can be classified, if we take an image, into a different class. There are few people who are just involved into their work. They can be classified into different class. So image classification, it refers to the labeling of images into one of a number of predefined classes. We have certain predefined classes, like some people eating, some people chatting, some people doing their work. So they can be classified. If we take certain images, we can classify these images into different classes. Let us understand with the help of some examples. If we talk about binary classification, labeling an X-ray as cancer or not. An X-ray has been taken. Now to label it whether it is cancer or not. That is a binary classification of the image. Second, multi-class classification, classifying a handwritten digits. Some handwritten digit is being used and to classify it. That is multi-class classification. Then again, we can have an example of multi-class classification, like assigning a name to a photograph of a face. If you want to assign a name of a photograph of a face, then that can be called as multi-class classification. So these are a few examples of the image classification technique.